Peter,
Yes.
you're on.
Yes, hello.
So, Peter, I'm going to go ahead and I'm going to share my screen, and I'm going to bring up your slides. Let's see, there it is. I should be able to see it now, Peter.
All right, starting with the Lunar Prospector mission. By the way, Lunar Prospector was my suggestion, and it was for the name. Now, here, this is of the northern hemisphere, and the pole is in the middle. And it shows that there are craters as far as 30 degrees from either pole, where parts of the crater are always in the shade and has ice. Now, while this is important for one reason, at the North Pole, all you've got is ice and moon dust. I had been reading up on basalt and learning how much you can make out of basalt. Cast basalt, you could cast cylinders for people to live in. You could cast furniture. You could fiber basalt. You can make fabrics. Right now, fiber basalt is used. Started in India and it's going worldwide on rebar, because steel rebar is going out of business because steel rebar rusts and basalt rebar does not. So I looked for on the moon, where is there a basalt area near either North or South Pole? Bang, Mare Frigoris, right at the top. It is just a few degrees below that 30-degree mark. And better yet, it's a very wide mare, and if you include Sinus Roris, even wider. So if you put a settlement, let's say on the east end of Mare Frigoris, and connected by cable to one at the west end, and so when dawn arose in the east, everybody along the way would have power, and they'd have power until the westernmost one was out in the dark.
There.
Now, if you go down a bit, Mare Frigoris is not just basalt, but there are regions here where several different chemicals are sufficient to be worth mining. Down below that, right here below is Mare Imbrium, and that was an enormous impact, which is shown on the far side too. But below you see the colors in red and orange here is where there is a very heavy amount of thorium. Thorium can be turned into uranium-233, which we can use to send nuclear ships to Mars. So I don't think there's any other way we're going to get to Mars faster with nuclear power than this. Okay. Screen out down. So here you get how you could turn thorium to nuclear fuel for Mars-run ships. Okay. And here again is a map of the Mare area, and you can see how fortuitously wide you've got from Mare Frigoris into Sinus Roris. And I guess that's the last slide. No, okay. Here's a slide of how you can make habitats people live in. You start with on the left-hand side with two exits to a street, which would be made out of an empty fuel tank. And as the family grew, you could add on, or if it wasn't family, if you were doing home businesses in there. These are just shows what could be done in those hoops there. There's a picture window, cabinets, a bed, a kitchen, so on. Now your habitats could have windows and made out of Alon. Alon is an aluminum ceramic that can't be broken, not even by a machine gun. And since your habitat had to be covered with soil, you could have a Z view setup where you've got mirrors. You can see out the side there, and you could do similarly with light. So thanks to Alon, we could have views to the outside and sunlight from the outside.
Yeah, I think there's one more slide.
One more slide. Okay. Let's see, bring it down here. Okay. Your cabins or where people live would be along this like this fuel tank. On both walls, you could have living walls. If you haven't heard of living walls, do Google living walls, green walls, and vertical vegetable walls. It's a new thing and it's expanding worldwide. Instead of using acreage, you use empty walls. And so you'd go from one house to the other or through the settlement, and you'd have all this vegetation. It would different. The kids could have a hand in designing it because you've got so many different kinds of plants and so many different ways of doing it. So this is an older picture. I haven't drawn a newer one, but you'd have homes on this side, homes on that side, living walls covering the surfaces there. You'd have sunlight. And is that the last one?
That's it. And so actually it's about time for Q&A. Type in your questions. I'm going to actually close off the share, and that way I can see both the chat window, the most recent questions. If you want to type in there, if you're a panelist and you have a question, just turn on your mic and Peter can respond. So anybody out there, if not anybody in my room, have a question for Peter? Nobody? Peter, talk about radiation and how much radiation shielding is required to protect from cosmic radiation.
Well, you would cover all the homes and the streets with enough moon dust, so you'd treat it just as we expected to do that.
Okay, and how much thickness?
Well, 6 foot or 2 meters might be enough in a short run, but in a long run you'd probably want double that.
About 4 meters, 4 or 5 meters. Okay, so a meter is 3 feet, just to suggest. So 3 foot times 4, that's 12 feet of earth on top of you.
Yeah.
Now, the good news is you're on the moon, so it's only got 1/6 the gravity. So your structure can hold a bunch more mass than it would on the moon. I mean, on the earth.
That's right.
So the building a structure that can hold 12 feet of moon dust, if you want to call it that, is not really any big deal. All right, we did have another question. Ed Tulis of our chapter. Is Peter's PDF available online somewhere?
Yes, yes, you've got both basalt and water on Mars, and your
That's fine.
great
PDF.
your great volcanoes are basaltic, and
What he wanted to know was, do you have a spot online where he can access your information?
online.
Online, internet-wise, a site on the internet?
I'm sure I do, but
Well, why don't you think about that one? And then I had another question. What was the other question?
I have a question.
Well,
I can't figure that out.
okay.
So, Peter, how do you envision the growth of human communities across the lunar surface in the next 50 years, assuming we do return to the moon in the next 5, 6, 8 years? And where do you see us 50 years down the line?
well, if we started now, we'd be quite far, but but we're not going to start until people realize that this is the way to do the moon, not the poles, where you've got
Not
both basalt, where you've got basalt and water. Now,
But certainly you can mine the water and oxygen from ilmenite, but that's very power intensive. Don't you think that water at the poles would be a lot easier to access? You know, you use sunlight there.
no, much to the contrary. In these craters, let's say 30 degrees from the pole, just a part of the southernmost part of the crater is in shadow all the time. So you could go into the part of the crater that's lit up and drive right onto the ice. No cables lowering you 2 miles down in the darkness.
And not only that, but the moon has got a lot of oxygen tied up in this material. So it isn't that you have to break water apart to get the oxygen. It's a lot more readily available. So the water is good, of course, for growing. It's also potential to get to the hydrogen, which could be part of a fuel, although there are other types of things that can make rockets than hydrogen. You can even burn aluminum, for that matter, if you have the oxygen, and there's plenty of oxygen on the moon, plenty. Anyway, Peter, I think we're about, go ahead.
Like I said, why use hydrogen when you could have uranium-233 nuclear fuel to go to Mars?